do a quick walk around of my customized Novacon Taurus Pro. I got the old stand style. This has got the Chinese BT30 spindle eye fitted Tico AC servos. And the controls are completely custom that I built. Quick look in the stand here. I have, it's hard to see, and I've cut away and have two large chutes for the chips and the coolant to come down. I got this recycling bin in here right now. I have to remake the front door. I cut the center divider out, as you can see, and I'll have to make one big door to go across. Moving around, I moved the oil lines for the head to the side here from the top. I bent all the lines out of copper tube. I got the cables going up to the top. This extra hose right here is my hydraulic for my spindle drawbar release. Should go back that real quick. Here is the Enerpac hydraulic cylinder. It's usually a work holding cylinder for like machining fixtures for high production. Got about a 1/2 inch stroke, and I think it's about a 1 1/4 inch diameter bore. This hose here is simply for purging the air. We got the supply coming from here, goes into the T, and then I've got this short length of hose, and then I happen to have a high pressure check valve, which is what this this device right here is. So I loosen up this cap and then cycle it, and it pushes the air and oil out. And when I feel it's adequately purged, I close that cap off and then just tuck this back inside the cover. This is a custom mount. This is the factory motor mounting plate. I am going to replace that with a steel one. There's a slight amount of flex, and I don't want that to be a weak link in the future. I currently don't have the Taurus nameplate, Novacon nameplate on here, but that will go back on. This is my drawbar release switch. This is the factory e-stop. One of the other things I did was I moved the oil line for the table over here to the left side. So it's right here with the proximity switch for the X direction. And that all runs through this heavy duty liquid tight conduit. In hindsight, this may be the better option that'll hold up to coolant in the longer run, but I should have gone with the high flex similar to what the machine came with factory. Actually, the factory one probably would have worked in this case. The factory flexible conduit is, I can't find anything like that anywhere, but it is very nice flexible stuff with a metal layer inside. Here is the control cabinet. I've got the Tico drive amps. This is the Z, it's a 1000 watt drive. And the X and the Y, these are 750 watt drives. And then my way oversized Hitachi VFD. This is the, I believe it's a WJ200 series. I had purchased this 5.5 kilowatt, anticipating using a 3 horsepower with a 5 horsepower overload motor. So I went a little big. Well, now I'm only running the factory spindle motor at 2 horse, so it's a little overkill, but it's here so I can upgrade in the future. I have a Banner safety controller. This will eventually be wired into 3 different e-stop buttons. The one on the front of the cowl or the headstock, the one that I have on an additional operator pendant, and one on the manual pulse generator, the little hand dial for jogging the machine. I have a 5 volt and a 12 volt power supply. These feed just the motion control card over here. It's just using a 4-pin Molex hard drive style connector. I have my 24 volt power supply, 4 amp. This does all my control logic. This this section here is for the 24 volt to distribute it. Again, this is the Dynamotion K-Flop controller and then the Dynamotion Canalog device. Up here I have encoder inputs, I have analog inputs, analog outputs. So the servo drives and the VFD are running an analog from the analog outputs here. They're taking an analog input signal for their speed. The analog inputs here I'm using for load. I have the 3 servos currently wired in, so their load is transmitted back to the card as an analog signal. I believe it is at full 10 volts is 300% output. I haven't done anything with the software yet to map that feature out and be able to watch the axes loads, and eventually I will add the spindle. I got some relays down here, coolant 1, coolant 2, and then this is actually like coolant 3. 1 will be for flood coolant, 2 will be for additional second pump someday to hose down the enclosure, and 3 is for the mist system or straight air system I anticipate adding. This relay currently is simulating the safety function. It's not proper OSHA safety compliant, but none of the systems on these small mills typically are. The e-stop button on the front of the headstock currently comes into this, and then this outputs to the drive safety wire that shuts down the servos. I got a relay here for the spindle fan, 1 for a spindle light I anticipate adding sometime in the future, and that is not focusing at all. My power drawbar relay, that activates, that is driven by the motion controller, and then this outputs to the solenoid on the air hydraulic booster I'll show you. This is an open spot I have. This is a little 6-bank relay card, and all this, all the terminal blocks and relays are from Automation Direct. This is a slick little one. It's a little more expensive than these other single pole. These are single pole, double throw, double pull, double throw. These are just single pole, single throw relays. They're a compact micro card. There's 6 relays in here. They got an LED indicator, and they have built-in suppression on the output side, so I can drive it directly from the motion controller without adding a diode, which you can see on these 2. I have added the diode, if you can see in the crappy video. And then this is a controller ready. There is a output on the motion control card that activates once the software has booted. So this here keeps power off to all the inputs and outputs, pretty much all the devices until the controller has booted. There are a few select devices that get power as soon as the cabinet is turned on. Down here I have a motor contactor. I believe it's a 40 amp rated contactor. I'm using this as my main power switch. So my 220 comes in up here, and then I have a switch on the front of the cabinet that activates this, and then this distributes power to everything else. This is just some distribution blocks. And I have all my fuses here. I got set for the VFD for the spindle, and 1 for each axis, 1 for the coolant pumps, and then 1 for the controls, and that does everything else, is kind of the controls. 2 EBM Pabst fans on either side. I got those from McMaster. These holes were open, all the other holes were open, so I found some 120 millimeter fan covers from some computer case manufacturer. They're a little thin and flimsy, but they work for plugging the holes. Here I've got a 20 ohm 1000 watt braking resistor. This was a eBay China special. It's a little big. I don't need 1000 watts, but the price was right. It was about 36 bucks. And down here, just sitting in the cabinet, is a Automation Direct 205 chassis with a DuMOR processor, some 16 input and 16 output cards, and then a serial, 3 serial ports, 1 RS 422, 485, and then 2 RS 232 ports. I plan on using the Modbus Master Slave program that came with the motion controller to add some inputs and outputs using that. And then this cable down here is actually for some future expansion for this. This is my operator panel, I guess. I don't have a full panel, so I've got a restart, cycle start, feed hold, stop, and an e-stop button, and this is just magnetic, so I can put it wherever I want on the front of the machine. Just hanging back here right now because it's not functional. Moving to this side, nothing special here. Just got some wires hanging out temporarily until I get some more conduits run. Up in the front here, that's the back of the power switch. Here's my oil lines coming out. I scored an automatic lube pump that has to get mounted. Sitting in here for now, so I can't knock it over again. I knocked it over and spilled all that oil that's missing. It was full. I went down to the floor yesterday. Another of the heavy-duty plastic liquid-tight conduits. This is from McMaster-Carr, where I got the other one. And then the air hydraulic booster. If the camera focuses here. Well, it's hard to see. It's an Enerpac B3006, I believe. Booster. This is the hydraulic line out. On the far side, over here is the solenoid valve, and then right in here is a large pneumatic cylinder, and on the other side is a small hydraulic cylinder. I think it's a 31:1 ratio, so at 100 psi I get 3100 psi of oil pressure. And that's about it for now. Oh, I do have these are the longer bearing rails for the Z. It extends down one link or one spacing here. This is all unsupported. Right now with this stop, the bearings have to stop there, but I could bring the bearing block down to about here in the future. And then up top, they extend one hole spacing above, and you can see the dirt line here. I can actually run the head up about that far. While that doesn't benefit the machining, that will benefit future tool changer. With the BT30 tooling and the pull stud, you need about 3 inches to clear the pull stud if you don't have the arm that comes down and inserts it into the spindle. So that's what I've done so far.